This is the output that's given, that's in the laboratory. I go to do experiments. So I have a measurement. So that's y0, y1, y2, yb, yl minus 1. I have L's data. L can be 100, can be 1,000. If L is 100 means I have 100 output data. That's Y. I call that's Y. Okay? Now what is the dimension of Y? Anybody tell me what is the dimension of Y? What is the dimension of Y? Assume my measurement, my device, I have only one measurement device. Then what is the dimension of Y? Huh? If I have only one measurement, only one measurement. Now, dimension of Y of Y0 is how much? That's 1 by 1, right? And my output, one output at the time t0. Now, Y1 will be also 1 by 1. So Y equal to Y0, Y1 to YL. So that is how much? That is 1 by L. Agree? Any problem? No. Okay. Now, if I have two measurements, if two measurements, available, then what is dimension of Y? Huh? 2 by L. 2 by L. So, that's just a trick. That just tell you that M is the number of outputs. So, the dimension of Y will be M by L. M by L. V. So I'm going to put V together. What is the V now? There's a V, big V here. Wow, it's nothing but I'm going to put all my input output together. One I call Y, one I call cap V. All right, V. Let's look at V. So we have to be careful about these dimensions. So I'm going to explain to you one by one so you understand. The same thing, U. Let's look at U0. Okay. Let's change this column here. Now, the same thing we have U0, U1, U2 to UL minus 1. Now, U is your input. So, U, the dimensional U of U0 will be R by 1, where R is number of inputs. right? Well, if you look at carefully, we know that the U is your input. Now you have I, if I equal 1, and so this, the whole matrix is, that one is, will be R by L. Agree? That's the same thing as the output. Any questions? I don't want to skip this because you have to understand about how I form the V. Okay. Now, if you look carefully here, I form a V. You know what I'm doing here now? It's easy. I will show you why I do this. Now I have a V equal to there. Alright, I have U0, U1, then U2, and so on. Well, you don't have to copy this, but anyway. UL minus 1. Alright, and I have V here. What is my V? I have a V0 here. Alright, V. Vk equal to UK YK. That's my V. That's my V. So, if this is UK is R by 1, YK is N by 1, so VK is R plus M by 1. So this is number input, this is number output. There's no complication here. This is nothing but I put the data, the input data and output data in a form. So I put input data in this form, Y form, like that. I put the input and output data in the V. Now I will show you why I want to do this way. Because if I do it this way, I will be able to compute alpha and beta. Alright, and then again, there's a V1 here, and there's a V0 here, and I have a big 0 here. Alright, that big 0, be careful, that big 0. This big 0. Alright. You have to be very careful about this big 0. Because this big 0, I assume the system, this big 0, we assume that the system is at rest initially. Assume the system you are under test. Alright? The system initially, all the initial state are 0. They are quiet. Nothing to do. Like this building. Now, earthquake is coming, assume this building is not shaking at all. And that's not true. Because we are moving. We are moving. You know, this building is supposed to also handle a reaction force. And this building moves through, and that's too small, no. So that big 0 here, we assume that like that. But if that's not true, if that's not 0 initially, then we cannot write this way. And we know that if we cannot write this way, then we have to ignore, we have to cut this V from here. We have to cut this V from here, because these are not 0. But however, we cut the front part from this line. From this line. Look at the line, look at my mouse here. We cut this line, and on the left hand side, cutting this line, because this involves 0. If we cut this off, then we don't have that problem because we have UP, VP minus 1, P minus 2, and V0, and this all got value. But however, we cut this one out, then we also have to cut this because this U0 corresponding to Y0, U1 corresponding to Y1, and U2 corresponding to Y2, and UP corresponding to YP. If we cut this line off, we have to cut the Y line and that off too. I'll explain that later. Okay, assume we know that definition. This is nothing but my input data, my output data, all I form this way. Okay, now the trick why I form this way because if I form this way, there's a formulation called Y equal to Y bar V. Then what is my Y bar? Okay, that's the trick. What is my Y bar? Y bar is this. Y bar is beta 0, beta 1, minus alpha 1, beta 2, minus alpha 2, beta 3, minus alpha 3, beta P. If you don't believe that, if I have Y bar here, you go back there, then you find out Y, I define like this, Y equal to Y bar V. Right? Okay. If we do it like this, now, you gotta believe this, and this is just an algebra. This is algebra. Alright, if I define my V is this way, I define my Y bar this way, I put all my unknown beta 0, beta 1, minus 1, alpha 1, beta 2, I will put this way, then you will find out that Y bar equal to Y. Let me write this stuff. Now we have Y equal to, I have Y equal to Y bar V. Alright, where's my Y equal to Y0?